A monkey is attached to a rope, and that rope is on a pulley. The pulley is a frictionless pulley, but not a massless pulley this time. So we see that there's 2.7 kilograms of mass on the actual pulley. So this rope will untwine as the monkey goes downwards. That's our job, to find the acceleration of the monkey and the force tension in the rope. So again, we'll start off by doing our usual. We have a gravity going straight downwards here. Okay, so then we'll take 35 times 9.8, and that's 343 newtons. And we have force tension upwards. And we're going to use this direction as positive and this direction as negative. So anything going round this way is positive. Anything going this way will be negative. So we'll look at the net force acting on the monkey, and we'll say that the force net is equal to force gravity minus force tension. Okay, that would be then mass times acceleration. So 35A is equal to 343 minus force tension. Okay, now what about the pulley? Now I've drawn just a sample of the pulley over here so we can see what's going on. We have a tension force pulling down, okay, on the pulley, and that's tangent to the circle, and then we have a radius r going towards the center of the circle. So this is a torque question then for it. So torque is then going to equal I alpha, okay, for the pulley. So we will have a system of equations, but something a little different than what we're used to. Let's write this over here. So torque equals I alpha, and let's substitute in what we know about this. Well, we know torque would then be force tension multiplied by the perpendicular distance to the center of rotation. So that's going to be force tension times radius. Okay. Now we have I alpha again. So I, the equation, is going to equal C mr squared. But a rotating disk, the C is equal to 1/2. So we're going to substitute in for I. That will equal 1/2 mr squared. Okay, now what about alpha? Well, we do know that A is equal to r alpha. So to convert an angular acceleration into a linear, you just multiply by radius. So then what is alpha equal to? Well, alpha, okay, will then equal A divided by r. So we're going to substitute both of these into our equation. So then we'll have 1/2 mr squared. Okay, and then we're going to multiply this by A over r. And we'll simplify that. So the radius here will cross off one of the radius values here, and then this will cross off the other. So it crosses off both. So force tension then is then going to equal 1/2. And I'm going to use a capital M right now, so I change it and then label that as an A next to it. Why did I do that? Well, we have two different masses, and we don't want to confuse ourselves. So we'll call the mass of the pulley a capital M, and the mass of the monkey a small m. So these are our two equations, okay, that we're actually going to use. So we have force tension equals 1/2 ma, and force net equals force gravity minus force tension. So let's substitute in this equation. Okay, I'm going to change colors to make this clear for us. So force tension is then going to equal 1/2 the mass of our pulley, which is 2.7, okay, multiplied by A. Okay, so now we have our systems of equations. Okay, I'm going to write that over here for clarity. So force tension is equal to 1/2 2.7 times A. Okay, so what are we going to sub in? Well, we have a force tension right here. We can sub that right in there pretty easily. So 35A is then going to equal 343. Okay, and we'll subtract a 1.35A. 1/2 of 2.7 is 1.35. So we get an acceleration value for this equal to 9.44 meters per second squared. Okay, last we need to find the tension, and you're looking at a nice equation here. So force tension is then going to equal 1.35 multiplied by 9.44. And force tension has a value of 12.7 newtons. And that's how we account for masses of pulleys in a frictionless rolling, so we don't have to worry about that.